Hey class, in today's lesson we're going to talk about analyzing data, which is found in section 11-5, part 1 of your book. Our objective is going to be to calculate measures of central tendency. So just a little vocabulary. It says statistics is the study, analysis, and interpretation of data. One way to analyze is by finding a measure of central tendency. A measure of central tendency indicates the middle of a data set. The mean, median, and mode are the most common measures of central tendency. And so again, a measure of central tendency is exactly what the word sounds like. It's measuring how likely or the tendency of something to be centralized. All right, so then we have our definition. So the mean is the sum of the data values over the number of data values. Median is if you put the numbers in order, whether it's from least to greatest or greatest to least, it is the middle value. If it's more than one middle value, you'll find the average of those two numbers. And finally, the mode is the number that occurs the most, okay? And here's something else. It says a bimodal data set has two modes. So if no value occurs more frequently than any other, then there is no mode. All right, so in example 1, we're finally going to start into it. So it says the frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode for the job offers per student? All right, so here's what's happening. When we're talking about job offers specifically, we need to basically be able to state how many times something is occurring. This is actually kind of almost like a tallied table. So we're going to need to expand this a little bit. All right, so for example, there are 2 students that got 0 offers, so we would write 2 zeros. Right now we're just trying to write our data. We have 2 1s. We have 4 2s. There are 5 3s. And there are 2 4s. All right, so now that we've expanded our data, we're going to find this information. All right, so to find the mean, we need to add up all these values and divide by the total amount. So 0 plus 1 plus 1 plus 2, 3. Uh-oh, I made a mistake somewhere, so let me try again. I got 33 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that's 2.2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, 2.2. And then the median, remember, is the number in the middle. So if I kind of cross these off, I'm going to just do 5 at a time. All right, so 2 is our median. And then our mode is the number that occurs the most, and that's pretty easy to tell from the table. The number that occurs the most is 3. And we are done. All right, so again, on try 1, we're going to find, right now what we have is a frequency table. And so we're going to need to expand those values and then find the mean, median, and mode for the trees per yard. So there is 1 yard that has 3 trees. There are 5 yards with 4 trees. So 1, 2, 3, 4, 5. There are 7 yards with 5 trees. So 1, 2, 3, 4, 5, 6, 7. There are 4 yards with 6. There's 1 yard with 7 and 2 with 8. So again, we're going to find the mean, median, and mode. All right, so if we find the mean, we've got to add it all up and divide by how many numbers there are. So here we go. 3. One way of doing this is also to multiply these numbers. So 3 times 1 is 3. Plus 4 times 5 is 20. Plus 5 times 7 is 35. Plus 6 times 4 is 24. Plus 7 times 1 is 7. Plus 8 times 2 is 16. That total is 105, and we're still going to have to divide by how many there are. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're going to get 5.25. All right, the median is finding the middle number, so let's say about, I'll say 7 on each end. I could really do 8. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 1. I really shouldn't have gotten rid of 2, but either way, these two are the middle, and that average is still 5. And the number that occurs the most is also 5, because we can see that by that number there. All right, some more vocabulary. It says an outlier is a value that is substantially different from the rest of the data set. If the data is arranged in order, outliers can occur at the ends. Sometimes an outlier is an important part of the data. At other times, it can be misleading because it affects measures of central tendency. So here, we're going to identify our outliers. So if we're looking at our numbers, we have about 55, 65, 73, 59, 98, 65, and 59. The number that stands out that is not like the rest is 98. So 98 is the outlier here. Here it says, suppose the values in problem 2 are the data for the situations below. Would you discard the outlier? Explain. So again, thinking about those values that we just had on example 2. So I'll rewrite them in case we've forgotten. It's 56, 65, 73, 59, 98, 65, and 59. So would we have discarded the outlier 98? And then we need to explain. So water temperature of a lake at 7 locations. Possibly, yeah. We might want to discard temperature because 98 degrees is a lot different than any of the other temperatures here. So I would say yes. Whereas the second one, it says the number of customers in a restaurant each night of the week. I would probably say for that restaurant, I would say no, because 98 might just be the busiest night of the week. Like it might be a Friday night or something similar, okay? So no, I wouldn't discard it based off of it being a restaurant. And guys, that is it. So remember, if you have any questions, please come see me for tutoring.